Welcome to the deep dive. Today we're diving into factor analysis.
Hmm.
It's a tool, really, for finding those, hidden structures within data.
Exactly. Uncovering the story underneath.
Yeah, think customer feedback, market trends. It helps make sense of it all. So, our mission today, let's unpack the core ideas, why it works, what the main types are, how to read the results.
And why it's such a valuable technique, really, for simplifying complexity.
Okay, so let's start with the main goal. Why do we use it?
Well, the primary objective is data reduction. You have lots of observed variables, maybe dozens of survey questions.
Right.
Factor analysis tries to identify a smaller number of um, unobserved constructs or factors.
Then you didn't directly measure.
Precisely. Factors that explain why those survey answers, for example, are related to each other. It's about finding the hidden drivers.
Okay, so take a big customer survey. Factor analysis could potentially tell us the three main things customers really care about, even if the questions were all over the place.
That's the idea, yeah, finding the underlying themes.
Now, I know there are a couple of main flavors of this, exploratory and
Confirmatory.
that's right, exploratory factor analysis, or EFA.
Yeah.
That's when you don't really have a strong theory beforehand. You're using the analysis to, well, explore the data and see what factors emerge.
Like digging for gold without a map.
Kind of, yeah. Whereas confirmatory factor analysis, CFA, is different. You start with a hypothesis.
You have a map.
You have a map. You think, okay, I expect these three factors, and these specific questions should relate to factor one, those to factor two, and so on. Then you test if the data actually fits your model.
Got it. So discovery versus testing makes sense. Now, once we have these factors, how do we connect them back to our original data? I've heard about loadings.
Ah, loadings. Factor loadings are key. Think of them as correlation coefficients.
Okay.
They show the strength of the relationship between each original variable, like each survey question, and the underlying factor that's been extracted.
So a high loading means a high loading, close to +1 or makers 1, means that variable is strongly related to that factor. It's a good indicator of what that factor represents. You look at all the variables that load highly onto a factor to understand and, name it.
Interesting. So a question about, say, website ease of use might load highly onto a factor we could call user experience.
Exactly. And sometimes you find surprises. A variable loads onto a factor you didn't expect.
Right. So how many factors should we be looking for? Is there a magic number?
Not really a magic number. There are statistical criteria, like looking at eigenvalues, but ultimately,
Yeah.
the goal is to find a number of factors that is both meaningful and interpretable.
Okay.
You want factors that explain a good amount of the original variance, but not so many that it just becomes confusing again. Parsimony is good.
Explain enough, but keep it understandable. Got it. Are there basic assumptions about the data we need?
Generally, yeah. You're assuming the relationships are sort of linear, and importantly, there needs to be some correlation between your variables to begin with.
Makes sense. If nothing's related, you won't find underlying shared factors.
Exactly. Factor analysis works best when variables cluster together, conceptually.
Okay. Now, what about rotation? Sounds a bit technical. Varimax.
Rotation. It's actually a really clever step to help with interpretation. Imagine your initial factors are kind of messy. Variables might load moderately onto several factors,
Hard to tell what belongs where.
right? Rotation, like Varimax, which is a common type, essentially adjusts the factors, mathematically spins them in the dimensional space to achieve a clearer pattern.
Here, how?
It tries to push the loadings towards either high or low. So ideally, each variable loads strongly on one factor and weakly on all the others. This is called achieving simple structure.
Simple structure. I like that. Easier to label the factors and understand what they mean.
That's the whole point of it.
Now, two other terms I sometimes see, communalities and eigenvalues. Quick definition.
Sure, communality is about the original variable.
Mm-hmm.
It tells you what proportion of that specific variable's variance is explained by all the factors you've extracted.
So how much of the website ease of use questions variability is captured by our factors?
Exactly. Eigenvalues, on the other hand, are about the factors themselves. Each eigenvalue represents the total amount of variance across all variables that is accounted for by that specific factor.
And eigenvalues help decide the number of factors, right?
Often, yes. Like the Kaiser criterion keep factors with eigenvalues over 1. It suggests the factor explains at least as much variance as a single original variable.
Okay, variable variance versus factor variance. Got it. Now, this sounds a bit like PCA, principal component analysis. How are those for? People often use them interchangeably.
Yeah, that's a common point of confusion. They both reduce dimensions, but the philosophy is quite different.
Okay.
Factor analysis fundamentally assumes there are underlying latent variables, these factors that cause the observed variables to correlate. It's about explaining the covariance.
Looking for the why.
Exactly. PCA doesn't make that assumption. It's more of a mathematical technique to create linear combinations, principal components, that capture the maximum possible variance in the data. It's about summarizing, not necessarily explaining underlying constructs.
That's a crucial difference. Factor analysis assumes hidden causes. PCA just finds efficient summaries.
You've got it. Factor analysis is theory-driven, in a sense, even the exploratory kind. PCA is data-driven summary.
And ideally, with factor analysis, we land on that simple structure where everything is nicely separated.
That's the goal for easy interpretation, yes.
So where do we actually see factor analysis being used out in the world?
Oh, loads of fields. Psychology is huge. Think personality trait models like the Big Five, or intelligence research. They rely heavily on factor analysis to identify core traits from lots of questionnaire items.
Right, finding extroversion from questions about parties and talking to people.
Exactly. Marketing uses it all the time, too. Understanding consumer attitudes, brand perceptions, maybe finding out that customer complaints about, say, delivery time, packaging, and product condition all really tap into one underlying factor of fulfillment quality.
Okay. Sociology, business research. Anywhere with complex multivariate data.
Pretty much. Anywhere you suspect there are underlying dimensions driving the patterns you see.
So wrapping up, factor analysis is really about seeing the forest for the trees, isn't it? Finding those key underlying drivers within a complex set of data.
It gives you a more streamlined, more fundamental understanding.
So a final thought for you listening. Think about areas in your own work or interests where you see lots of related data points, surveys, feedback forms, performance metrics. Could there be just a few hidden factors driving most of the variation? What might those unseen forces be? Factor analysis might just give you the lens to find out. Definitely something to mull over. Thanks for this deep dive.